Okay, y'all, today we're going to be looking at partial fractions, which is honestly one of my favorite concepts in Calc 2. I don't know, once you get into the rhythm of things, then everything works out and it's actually really nice. So a couple of things to consider when we're talking about partial fractions. In other words, we're trying to take a rational function like this, p of x over q of x. Both of those are polynomials. So rational function is when I put a polynomial over a polynomial. So I'm trying to break that up into chunks that when I add those chunks together, I will get what I originally started with. So a couple things to think about. If we have our top degree, make sure that the degree of p of x is less than the degree of q. If it's the other way around, so like, for example, if I had 2x squared plus 5x plus 10 over x plus 4. So if my degree on top is larger than my degree on bottom, then I can actually do long division. So like here is an example where I would do long division, actually divide those out. If you want a little review on long division, here's like x plus 4, and I'm dividing that into 2x squared plus 5x plus 10, but there will be a problem later on where I'll actually show that, and I'll show long division. I'll also show the box method, which is like my favorite thing ever. Okay, so if we're not performing long division, then we need to look at our denominators. So this q of x that's on our denominator and write it into factors. So if they're like multiple factors, then I can write it into factors, and then those are going to be the fractions that I'm going to turn them into. So there's a lot of kind of rules here, but we'll talk about them as we're going on. I actually just want to jump into this example. And so you can already see the degree on our top is 2, our degree on our denominator is 1. So I can actually just do long division in this case. So I'm going to do x plus 1, and that is dividing x squared plus 3x plus 5. Okay, so x goes into x squared one time, and I'm left over with an x. So now I can do x times my x here gives me x squared, and then x times this 1 gives me a plus 1. And I'm going to be subtracting not just my x squared, but also my x up here. So these two things will cancel out. I'll have 3x minus x to give me a 2x, and I'm going to bring my 5 down here. And now this is what I'm dividing by. So I'll have x goes into 2x twice. So 2 times my x here gives me a 2x, which is what I wanted. I want those to cancel out. 2 times my 1 gives me a plus 1. And I am going to subtract both of those. So subtract this. I'm also subtracting this. 5, these cancel out. 5 minus 1 is 4. So that will be my remainder. But then we started to write remainders as 4 over x plus 1. So essentially what I have done is I have rewritten this equation in some easier steps. So I've rewritten it as x plus 2 plus 4 over x plus 1. Now when I take my integral of this, I can take my integral of each individual part. So my integral of x is going to be x squared times 1/2. My integral of 2 is going to be 2x. And now I kind of have to think about my integral of 4 over x plus 1. And if it was just like a 4 over x, then I could see that as like a 4 times 1 over x, and I know that my integral of 1 over something, 1 over x in this case would be ln of x. But since this is like an x plus 1, I kind of want to see this as my inside part of my function that I'm going to find. So I can use u substitution on this. It's just going to feel a little silly, but u is equal to x plus 1. So my derivative of u is just going to be 1 dx. And so really I can rewrite just this chunk right here as my integral of 4 over u du. And then now it's just 4 ln of u when I take my integral plus c, of course, and I can re-plug in my x plus 1 right here. So altogether, my final answer will look like my chunk that I have, just positive 1/2 x squared plus 2x, and then plus 4 ln of not just u, but of x plus 1, and then plus, can't not forget my plus c. technically this should be absolute value right here, but because we can't plug negative values into my natural log, because nothing raised to an exponent will give me a negative, if you think about that exponentially. I want to take a look at question number 2. So this one is written a little bit differently because my denominator degree of 3 is now larger than my numerator degree of 1 right here. So this has a degree 1. So I'm going to have to think about doing this in a slightly different way. And I'm going to kind of focus in on this denominator part. So my x to the third minus x squared minus 2x. And I want to try to factor all of these out. So I can factor out an x from all of them. Oh, and then now my x squared minus x minus 2, that can be further factored into an x minus 2 and an x plus 1, because negative 2 times 1 is my negative 2, and negative 2x plus 1x will give me my negative 1x that I have right here if I distribute all of this out. So each of these factors are unique, and so essentially what I can try to do here is I can take my integral of 3x plus 2 over x times x minus 2 times x plus 1, because that's what it is all factored out, dx. And I can rewrite this as something that is going to be over x plus something that is going to be over x minus 2 plus something that is going to be over x plus 1. So each one of my factors of my denominator. So now what I really need to find out is like, what is this a? What is that a going to be? And I'll end up taking my integral of each one of these parts after I actually figure out what this inside part is going to be. What is my b going to be? What is my c going to be here? So I am solving this type of an equation, and already I'm kind of overwhelmed with the denominators. So to get rid of my denominators, I'm actually going to multiply times x minus 2 times x plus 1 on every single one of these. So this will be times x minus 2 times x plus 1. And so what that has done is now I've multiplied everything by the same thing. My goal is to kind of get rid of my denominators and this division or fraction. So these x's are going to cancel out. This x minus 2 and this x minus 2 are going to cancel out, and my x plus 1 and my x plus 1 are going to cancel out. So really, a will just get multiplied by x minus 2 times x plus 1. B will get multiplied by x times x plus 1. And c will get multiplied by x and x minus 2. I'm going to go ahead and write that. Now I'm going to go ahead and start distributing everything that is like in parentheses along with my a's and my b's and my c's. And I'm going to leave this 3x plus 2 over here on my left-hand side. Okay, now that I kind of have it written like this, I am going to look at kind of comparing my coefficients. So for example, right here I have a 3 that is in front of my x. And so I know that here is an x term over here, negative ax, and plus bx, and minus 2cx. Those are all my x terms. I want to go ahead and compare those, and I'm going to write them as one equation, because I know that whatever negative ax plus bx minus 2cx is going to equal, it's going to have to equal my 3x over here. So really, once I have this equation, now I can kind of factor out my x, and I know that 3 is actually going to be equal to my negative a plus b minus 2c. Now I have a system of equations, which is 3 is equal to negative a plus b minus 2c. And I'm going to look up here at my original equation that I started with, and I'm going to do that with anything that doesn't have an x. So I think the only thing that doesn't have an x is like this one. So in other words, 2 is going to be equal to negative 2a. And that's an equation kind of all on its own. But you can see that I have some x squared terms actually left over. So I have this x squared term, this x squared term, this x squared term, and I have no x squared term over here, which is because I have no x squares. So this is going to be my third equation that I have. 0x squared is going to be equal to ax squared plus bx squared plus cx squared. And if I factor out an x squared from all of these terms, I'll just be left with a plus b plus c, which that is what is going to equal my 0, because that's what's in front of my x squared term over there. So 0 is equal to a plus b plus c. Okay, I have now 3 equations, and I had 3 unknowns. So if I look up here, I was really trying to figure out what my a, my b, and my c are. Now I have everything that I need to actually solve that out. So I think I'm going to start solving that by starting with my easiest equation, which is going to be this equation number 2 that I have right here. So for equation number 2, I am just going to solve for a by dividing by -2. So a is actually going to be equal to -1. So already up here in my equation, I can have -1 over x, and now I can look for solving for what my b and what my c value are going to be. So I'm going to solve for those b and c values by plugging in a over here and plugging in a over here. I'll have 3 is equal to negative times negative is +1 plus b minus 2c. And if I solve that out by subtracting 1, I will get this type of an equation. Now I'm going to jump over to equation 3. I'm going to plug in -1. So -1 plus b plus c is equal to 0. And if I move that 1 over, I'll just have b plus c is equal to 0. And actually, there's lots of ways that you can solve this. You can solve this with substitution. You can solve this with elimination. This is kind of set up perfectly for a substitution. So if I solve for either this b or this c over here, or just this b that's by itself, I can replug that into my other equation and then solve for my other variable. I'm actually just going to choose to solve for this b. So I'm going to subtract c on both sides. And then now I can replug this in for my b over here. 2 is equal to 1 minus c. So I substituted this b with 1 minus c minus 2c. And now I have an equation with just all c's, and I can solve for that c. So in the end, I get that c is equal to -1/3. I'm going to now replug that into my equation of 3 right here. So I have 1 minus a -3rd, so it'll be 1 plus 1/3. B will be equal to 4/3 here. I have grabbed my equation from up above. This was originally my a, which is now -1. This was originally my b, which is now 4/3. And this was originally my c, which is now -1/3. My whole goal was to find the integral of this with respect to x, and so I can do that by taking the integral of each one of these terms, which first one, not too bad. My -1 is a constant. Integral of 1 over x is just ln of absolute value of x. And I could also use substitution on these other ones, but as long as it's just an x that is solo, not like a 2 in there, so we're not having to use the opposite of chain rule, as long as it's just like a 1x in here plus some constant, I can know that my 4/3 is my constant, and then my integral of 1 over x minus 2 is ln of absolute value of x minus 2. And then same thing over here, 1/3 is my constant. Integral of 1 over x plus 1 is going to be ln of absolute value of x plus 1. And then I cannot forget about my c. So we took this seemingly impossible problem, we broke it into parts, and then we took the integral of each part. That is why this is called partial fractions, because we write them each part as a fraction. Okay, y'all, I want to look at example number 3. So again, kind of checking your numerator, your degree of your numerator and your denominator is a good place to start. Our degrees of our numerator and denominator are the same, which is the degree of 2. And so we're going to have to do something just a little bit different. I know that I said that I would talk about long division, which we did in the very, very first problem. I'm going to use something right here that is called the box method of dividing, and so it's actually really, really similar to long division, but for me, it's just a little bit easier. So I want to demonstrate this. You don't have to use this. You can always do long division, but this one is kind of helpful. So my x squared plus 3x plus 1 is going to go inside of here. So I'm going to have x squared right here. And I know that it's really just a 1 times my x squared to get me this x squared. But I'm going to follow this through. So this will be a 1 times a negative 4 right here, which will be, yeah, negative 4. And then my remainder that I would need would be a 3x, so I'm missing a 3x, and I also have a plus 1, which I want that to be on the inside. So if I add 5 here, those things will combine to be a plus 1. So my remainder R kind of looks like this. Another way that I could write it is as 1 plus and then 3x plus 5 divided by, this is what I was dividing by over here, which is x squared minus 4. So I want my degree on my top to be less than my degree on my numerator when I'm doing partial fractions. And so now I'll take my integral of each of these, but I'm going to split this up into 2 different fractions. So I think that's x plus 2 and x minus 2. Yeah, so I'm going to split this up into 1 and then plus, I'll figure out what my a is going to be over my x minus 2, and I'll figure out what my b is going to be over my x plus 2 that I have here. Once I do that, then I can take my integral of those. To just make my life a little bit easier, I'm actually just going to look at this fraction right here compared to what I'm trying to split it up, because if I subtract 1, I'll just get a 1 on both sides. So that 1 is still there, but I'm just going to kind of focus in on the partial fractions part of it. And so I have all these fractions. I'm actually going to multiply by my x minus 2 and x plus 2 to each part. Here it'll cancel out with that denominator. When I multiply by x minus 2 and x plus 2 here, my x minus 2's are going to cancel out, so I'm really just multiplying by x plus 2. And kind of the same thing over here, my x plus 2's are going to cancel out, so I'll really just be multiplying by x minus 2. Now I'm going to distribute these out and compare my coefficients, so stuff in front of the x and then in my constant terms. So one of my equations is going to be 3x is equal to ax plus bx. So in other words, I can really say that a plus b is going to be equal to 3 in this case. And I can do that same exact thing for my 5 is equal to 2a minus 2b. So 5 is equal to 2a minus 2b, and now I have both of my equations that I can either combine through substitution or elimination. Since I did substitution, I solved for like an a or a b on the other side. I'll go ahead and I'll try elimination on this side, which means that I want to combine these equations in a way where I stack them on top of each other and add them together, I will eliminate a variable. And so if I put my 3 is equal to a plus b right here, I can see that my b's are almost going to cancel out. I just need to multiply this by 2 so that I have a 2 positive 2b on the side and a negative 2b up here. So I'm going to multiply everything by 2. I have 6 is equal to 2a plus 2b. And then I'm going to add that with my equation that did not change up here. And I can see that my b's are going to cancel out. I'll have a 4a is equal to 11. So that means that a will be 11/4. So now I can actually re-plug that into, it doesn't matter what equation, but I'm just going to plug it into my first equation over here. 11/4 for my a. And so if I subtract 11/4 from 3, I will get that b is equal to 1/4 because 3 is the same thing as 12/4. So I'll have 12/4 minus 11/4, which will be equal to 1/4. My b will be 1/4. Now I can re-plug in my a and my b in my original equation that I had up here. Actually, my original equation, which I had up here. So I don't want to forget that 1. Okay, so I now have that my original equation is going to be equal to, this was my A, which was 11/4, and my B, which was 1/4, and I can take my integral of each of these with respect to x, integral of each of these with respect to x, which I will get x plus 11/4 is my constant, and then ln of x minus 2 plus 1/4 ln of x plus 2 right here, and then plus c. And I've taken this again, yet seemingly impossible problem and broken it up into chunks. The next 2 examples are going to be on a different video.